Hey there, future aviators, and welcome to this Masterclass Explainer. I'm your host and instructor, Captain Pankaj Pahil. I've spent the last 17 years of my life teaching and flying all over the globe, and today we're taking all that real-world experience and channeling it straight into your official DGCA exam prep. We are tackling aviation meteorology, specifically diving deep into clouds and obscurations. Now, I've custom designed these visual notes to be the ultimate interactive study guide for you. And yeah, you'll definitely notice my name watermarked across every single frame. That's just to protect this exclusive material, so make sure you're paying close attention and taking great notes. Let's get started. I actually want to kick things off by getting our mindset right with a quote I love. A mile of highway will take you a mile. A mile of runway will take you anywhere, but only if you respect the weather. Look, we aren't just studying meteorology today to scrape by and pass a DGCA paper. That's not the goal. We're studying to make safe, critical decisions out there as future captains. The sky out there, it doesn't grade on a curve. So let's make sure we get this right. All right, here is our game plan for today's explainer. 1. Signposts in the sky. 2. Diagnostic definitions, specifically base versus ceiling. 3. Measuring the cloud base. 4. The master classification framework. 5. The convective threat. And finally, number 6, our master DGCA cheat sheet. Okay, let's dive into section 1, signposts in the sky, visual warnings for pilots. Before we bog ourselves down with all the heavy definitions, we need to talk about why we even care about clouds in aviation in the first place. I mean, clouds aren't just pretty scenery for your passengers, right? They are literally nature's warning signs. They are explicitly alerting us to 4 major operational hazards. First up is turbulence, that bumpy air that can seriously compromise your aircraft control. Second is poor visibility, which completely dictates whether we can cruise along under visual flight rules or if we suddenly need to rely on our instruments. Third is precipitation, so rain, hail, or snow. And finally, icing. Icing is a silent killer that physically changes the aerodynamic shape of our wings. So whenever you see a cloud, the very first question you need to ask yourself is, which of these 4 threats is it hiding? Now, to communicate exactly how much of a threat is out there, meteorologists measure sky coverage using something called the octa scale. It basically divides the entire sky into eighths. And listen up, because this is a guaranteed DGCA exam point. 1 to 2 octas is considered few, and 3 to 4 octas is scattered. But the absolute critical cutoff happens at 5. Only broken coverage, which is 5 to 7 octas, and overcast, which is a solid 8 out of 8 octas, officially constitute a ceiling. Remember that rule, it's incredibly important. Moving right along to section 2, diagnostic definitions, base versus ceiling. This is a very crucial DGCA distinction. Let's tackle a notorious trap that constantly trips up students on the exam, mixing up the cloud base and the cloud ceiling. Let's contrast these two directly so you never forget it. The cloud base is simply the lowest zone where the clear air haze perceptibly turns into water droplets or ice crystals. Think of it as just the physical bottom of any given cloud. But the cloud ceiling? That is a strict operational definition. By definition, it is the height above aerodrome level of the lowest layer of cloud that covers more than 4 octas. To really visualize this difference, picture some scattered clouds hanging down low. They absolutely have a physical base, sure, but because they're only covering, say, 3 octas of the sky, they do not form a ceiling. The ceiling is measured specifically from the surface level straight up, straight past those scattered clouds, all the way up to a dense 6-octa broken layer sitting way up at 25,000 feet. That higher layer is your ceiling. Whatever you do, do not mix those two up on your exam. Let's jump into section 3, measuring the cloud base. We're going from balloons all the way to lasers. So, obviously, knowing the exact height of that base and ceiling is absolutely vital. But how do meteorologists actually calculate those numbers for our weather reports? It's a pretty cool evolution, actually, across 3 different eras. Back in the day, they used to literally just release a balloon with a known rate of ascent and use a stopwatch to time how long it took to disappear into the cloud. Basic, simple math. Then, at night, they shifted to using a searchlight positioned at a known distance from an observer. The observer used a neat little tool called an alidade to measure the angle of the light beam, and boom, they calculated the base using trigonometry. Pretty clever, right? But today, we've gone totally high-tech. In the modern era, we rely heavily on laser ceilometers. This is, without a doubt, the most accurate method currently in use. Here's how it works. A laser pulses completely vertically into the sky, hitting the cloud base, and the receiver down below measures the exact time it takes for that light scatter to reflect all the way back down. Speed of light, time of travel, bam, you have incredibly precise altitude data ready to go for your METARs. Moving on to section 4, the Master Classification Framework, categorizing the sky. All right, so now that we know how to measure these clouds, we really need to know what to call them. Seriously, grab your pens because you're going to want detailed notes on this Master Classification Framework. Every single cloud globally is categorized on a specific grid based on just two things: their physical shape, which we call form, and their base altitude, which we call level. The Latin roots are the secret here. They tell you the shape. Stratiform means it's layered and horizontal. Cumuliform means it's heaped up and vertical. And cirriform means it's wispy, almost hair-like. We then take those shapes and intersect them with high, medium, and low altitudes. It's like a giant puzzle. And here is exactly how that puzzle maps onto the actual troposphere. You need to emphasize these crucial altitude boundaries in your notes. Low-level clouds sit right from the surface up to 6,500 feet. Medium-level clouds, which we identify with the prefix alto, live comfortably between 6,500 and 23,000 feet. And our high-level clouds, using the prefix surro, exist all the way from 16,500 feet right up to the tropopause. Oh, and definitely notice that there's a bit of an overlap region there between the medium and high levels.
Let's zoom in on that middle layer for a second, the alto clouds. They have some very specific visual diagnostics. Alto stratus, for instance, often covers the whole sky and gives the sun a distinct ground glass effect. You can see the sun, but it's blurred out, kind of murky. Then you have alto cumulus, which usually appears as speckled white or gray patches, honestly looking almost exactly like a flock of sheep hanging out in the sky.
Now, putting my instructor hat firmly on here, I need to give you a stern warning about two very specific, very dangerous variations of altocumulus. First is altocumulus lenticularis. These look like smooth, stationary UFOs, but do not be fooled. They indicate the presence of dangerous mountain waves and severe downwind turbulence. Next up is altocumulus castellonus. These literally look like little castle turrets jutting up. If you spot these on your morning walk around the ramp, it points to immense summer instability and pretty much guarantees thundery, stormy weather later in the day. Let's move way up to the high-level cirroclouds. And hey, I finally have some good news for you. Because these sit above 16,500 feet, they are composed strictly of ice crystals. What does that mean for us? It means turbulence and icing are generally nil, zero. They are beautiful, they are benign, and they are safe. Just make a quick note for your exam that cirrostratus is super famous for creating a highly visible, almost perfect halo around the sun or the moon. Time for Section 5, the convective threat, understanding cumulonimbus. All right, shake off the relaxed vibe of those high-altitude ice clouds because we are now shifting into the absolute, most severe danger zone in all of aviation meteorology. I need your absolute, undivided focus here. Think about the stark contrast between two very different cumulus formations. On one hand, you have benign, fair-weather cumulus clouds. Glider pilots absolutely love these little guys because they indicate gentle thermal upcurrents. But when you have deep, moist, unstable air vertically throughout the atmosphere, that benign cumulus completely mutates into a monster, the massive, towering cumulonimbus, or CB. This thing is huge. Its top can reach all the way to the tropopause, forming that characteristic flat anvil shape. The cumulonimbus is, without question, the undisputed king of operational hazards. If the DGCA asks you about CB hazards, write these exact answers down: severe turbulence, severe icing, lightning, and hail. Inside that cloud, you have massive, violent upcurrents and downdrafts, literally tearing at each other. For a pilot, a cumulonimbus is an absolute, non-negotiable, no-go zone. You don't try to fly over it, you definitely don't fly through it, you fly around it, and by a very, very wide margin. And finally, Section 6, our Master DGCA cheat sheet, the final review. Let's bring this entire masterclass together with the ultimate revision tool for you to review before you walk into your exams. Seriously, take a screenshot of this complete hazard matrix, whether mentally or physically. Notice how perfectly the threats scale logically based on everything we've talked about today. Down at the bottom, those high-level ice clouds have NIL turbulence and NIL icing. You're completely safe. But as you move up the chart into the low and medium layers, those threats start turning orange and then red. Nimbostratus brings moderate to severe icing, and of course, cumulonimbus lights up the entire board with severe multi-threat environments across every single category. I'm going to leave you with this final thought. Yes, memorize the octascale, learn the altitudes, and absolutely go crush your DGCA exam. But more importantly than any test, look at the sky. I want you to internalize these notes as a lifelong commitment to the safety of your aircraft and your future passengers. Because when the sky is out there speaking to you, dropping a really subtle hint with a Castellanus cloud, or throwing up a massive cumulonimbus signpost right in your flight path, Well, you know how to listen. Thank you so much for joining me, Captain Pankaj Pyle, in this explainer. Keep studying hard and fly safe out there.